Okay, in this tutorial I'm going to help you analyze your results for site 8, which may be your last site depending on how much time you get to complete all of the 9 sites that we were hoping to visit. Before you watch this, you need to have written up your analysis for site 7, because to understand the results of site 8 you need to understand what was happening at site 7. Now I am starting at the duck pond, which lies between site 7 and site 8, and the reason for starting here is that if you've watched the previous tutorial you will know that the water from the river had been extracted prior to site 7 to fill this pond, which I happen to be standing right next to. And it's important to understand this because site 8, which I will be walking to in a second, lies just after the water from this pond rejoins the river. So I'm going to show you where that happens. So we're at the other end of the duck pond from where we were at site 7. And you can see, if I just walk around here, that we have an outflow from the duck pond right there on the camera. So the water's coming in at one end, having been taken out of the river prior to site 7. It then flows out the other end of the duck pond, which we can see happening right here. And it goes under the path here in a pipe, and it flows back into the Anity Burn right there, and you can see it. So it's almost acting like a small tributary, and there is the Anity Burn in the distance. Now site 8 happens to be a location just after this, and I'll go down and look at that location, and we'll explore what this sudden increase in discharge is going to have done to all of the 4 main characteristics being investigated. Okay, here we are down at the riverbank at site 8 on the Anity Burn. The water from the duck pond has now rejoined the river just upstream from the site that I'm standing at, and therefore our discharge will have jumped noticeably because of this the water rejoining our river channel. Now the question is our discharge back up to the level it was at site 6? Because if the water was extracted to the duck pond but has now rejoined the river again, we would expect the discharge to have bounced back. However, in all likelihood, the discharge will not have achieved the level it was at site 6, and the main reason for that is to do with the geology. One of the aspects of sandstone is that it is a soft, porous rock, and if I just come down here to show you this, on this piece of sandstone down here, and it's very soft and crumbly, as we can see. It just breaks away quite easily, and water can absorb into this rock because it has holes, or it's porous. It's what we call permeable, and because the base of the river channel has this rock, it's likely that a lot of the water is percolating, and that means the water is soaking into the rock and being lost to the river channel as it's starting to flow as groundwater underneath the river itself. Therefore, at this stage, due to a geological change, our river channel is actually not got as much water in it as it had at site 6, but it certainly should, and we would expect our data to show that it's got a lot more than it had at site 7 when it had lost a lot of water. There is one other factor that we can see that might explain the increase in discharge. It might not just be to do with the water from the pond rejoining, but we can see all along this river there's a number of these. If we go upstream, we find them about every sort of 10 meters. These are large black pipes that run up the hill to the farmers' fields, which lie just at the top of that hill. If you looked at the NOAA's map, you'd see that would be the case. And what farmers are doing is they've got whole drainage systems in their fields, and when it rains heavily, the water drains through these ditches into these black pipes, and then water just pours or drips out of these pipes. We can actually see there is a little bit of water even coming right now out of the pipe, and that water feeds the river channel. So after site 7, in between site 7 and 8, there's been quite a lot of this activity. Now let's just very quickly think about our other 3 variables. Has river efficiency, or its hydraulic radius, increased? Now we can certainly see that this river now has got a substantial depth to it. You know, it looks like it's at least sort of 50-60 centimeters depth. It's got reasonable width, so a lot of the water is flowing quite freely. We can see at this location there's very little large boulders interrupting the flow of the river. or acting as a brake. And therefore we would expect the efficiency or the hydraulic radius as it's known to have increased from the previous site. And that's especially because the river's got more water in it. Because its discharge has increased, we'd expect it to be more efficient now. Its rock shape, we can see very little in the way of angular boulders in the river. They've all been very smooth due to attrition. This is partly because of it's still sandstone rock, and therefore we're expecting it to have been further smooth as a lot of these rocks have moved downstream. However, there are some angular rocks, and the reason for some angular rocks, we can see a little collection of them here, is that these rocks are coming down from the riverbanks, breaking off because of freeze thaw. We can actually see some loose rocks here that can just cracks in these rocks, and in winter time a lot of these rocks, we can see one there, will just break off like we can see has happened. And when the river's absolutely full of water, some of these rocks will actually get moved towards the river channel over time and will then be in the river channel. So I would be expecting my data to show that there's still some angularity to the rocks, but in general the majority of them should be rounded to some degree, and that's because of the geological change. So make sure you do sort of address the fact that should be expecting lots of rounded rocks. However, there might still be some angular, and explain that's to do with erosion on the riverbanks due to freeze thaw breaking off rocks, and that there was evidence of that. We can see that right here. Okay, in terms of rock size, I would expect rocks still to have got smaller. We can see plenty of small rocks in our river channel. However, also, once again, I wouldn't expect a big change in rock size, and that's due to the larger boulders rolling off the sides. And of course, if you have one large boulder like this one, you could pull out 9 small rocks and have one big one. And of course, the large one causes your average rock size to increase. So I wouldn't expect your rock size to show a dramatic change from the previous site. So what we're going to do is we're going to just go down and explore site 10 to see what the river does just before it joins, before the river mouth itself and before the end of the Amity Burn. And you might get time on the day to have gathered the data, and we'll look at the reasons that might explain the data that you see.